Hi guys, we're Group 17 and today we'll be showcasing the step-by-step procedure of creating embedded system enclosure for a smart switch for our coursework number 3. First, we set up the parameters, as you can see in this portion of the video. And then, we use these parameters to create a rectangular sketch of 50mm by 70mm and then extruding it by a thickness of 5mm. Next, we create a sketch on top of the plane of our rectangle and sketch a smaller rectangle from both of the edges with length 50mm and width 5mm. And two more rectangles from the top and bottom edges with a width of 70mm and length of 5mm.
This creates a border for our enclosure as we select the 4 rectangles we just created and extrude it by 25mm, and now we have our box. Now, we select the corners of the outer edge and the inner edge and fillet it by 5mm to give a rounded edge. Now, we go to Insert and Insert Component and select the ESP32 Super Mini or our microcontroller from our step file, and we place it inside our box. Now that we have our microcontroller, we want to make sure that the end of the USB connector housing is sticking out of the box in order for us to be able to communicate and get power from another device, usually a computer. First, we need to create a hole for the USB connector housing, and we do that by sticking the microcontroller against the wall and tracing the edge of the USB connector. Now that we have traced it, we simply highlight it and extrude it by -5mm to create the hole. Next, we insert another component, the RF6001, which is an ACUS 2-pin outlet plug, which is what we use for direct wall electricity. We rotate it by 90 degrees and place it against the right side of the box. Next, we select the face of the outlet plug and capture its position before sketching a square along the outlines and extruding a thickness of -5mm to create our hole for the outlet plug.
Next, we import another step file, a momentary button switch for manual input of turning the application on and off. We rotate it by 90 degrees and place it against the front side of the wall. We then create a sketch from the face and trace its outermost edge to create a hole for the switch. Next, we input another step file, the 5mm RGB LED light. It basically provides visual feedback about the system's operating status. Yet again, we rotate it by 90 degrees and place it beside our switch, placing it against the wall and creating a sketch on its face and extruding it inwards to create a hole for it.
Now that we have all of our components, we go to our top view and create a sketch by capturing its position and selecting the operation new body. Extruding it by 2mm, it gives us a solid surface on top which closes our box. Next, we create another sketch on our top surface, drawing a line 2.5 mm from the top and side edge. Now, we want to create a reference circle based on the filleted edge and draw a line from our intersecting lines towards towards the center of the circle. Now, we create a triangle from the center of our top surface and have its edge connect to the midpoint of our line from the circle. The purpose of this sketch is to create the center point of where we will place our screws. Now that we have our rectangle sketch, we can now delete our reference points. Next, we create a hole from the corner of our rectangle, selecting hole type, countersink, hole tap type, tap, thread, full, and drill flat as we use M2 screws sized 8.0 mm. We can see that the hole of the screws goes through the top surface and into the main body. Now, we input our screws from selecting Input Master Car component and search for an M2 socket head cap screw. We make sure its thread size is M2 and its length is 8 mm. Once we find the matching component, we simply download its file and it imports directly inside Fusion. Now that we have our screw, we select the bottom part of its head, selecting Join, and joining it to one of the holes, and do it for the other 3 screws. Now that we have screwed the top, we go to our top view, create a text and label it Smart Switch, and then extruding it by -1 mm.
That concludes our step-by-step process of creating an embedded system enclosure for a smart switch using Fusion 360. Through this design, we were able to integrate both the electronic components and mechanical structure into a single functional enclosure. This project demonstrates the importance of combining hardware awareness with emerging technology design principles, especially in embedded systems where precision and component placement is critical. Thank you for watching our presentation. Again, we are Group 17.